Hello, everybody. Welcome to the July New York JavaSIG meeting. So good evening, good afternoon, good morning, wherever you are out there. Today we have the opportunity to hear from Johannes to talk about debugging. Johannes is in the area, and even though it's right before a U.S. holiday, and thank you all for showing up right before the holiday, we thought it'd be a great time to have Johannes talk to us. So before I turn it over to Johannes, I wanted to thank Bank of New York Mellon. Thank you very much for supporting the Java user group and giving us the room. Thank you very much, Dave, for hosting us. Thank you. Our next meeting, I just want to let you know, the end of the month is the 31st, I think. We have Sean Phillips going to talk about using Java to discover deep fakes, to detect deep fakes, which is pretty cool, using Java itself. So that'll be a really cool talk, and not just for Java people, for security and for AI people too. I also wanted to mention that James Gosling, we all know who James Gosling is, right? The inventor of Java. He announced today on LinkedIn that he is officially retiring.
Oh,
so congratulations to James. Congratulations, James. He certainly had an impact on my career over the past 25 years. So thank you, James. Okay, so let me turn everything over to Johannes and talk about Java debugging.
Hi. Let's see when the camera catches me. Modern technology, probably not written in Java. Anyway, I'm talking about debugging and how to look behind the curtain of debugging, because that's what you will like to do, essentially tell you more about. So when we talk about debugging, we're not talking about these things. This is one of the first bugs discovered. Here it says, like, where is it first actually case of a bug being found? The only problem is it's not a bug, it's a moth. So you probably all notice when you're at home and the moth flies in, you're like, and sometimes when they fly into your bulbs, it was in the olden days. Some will remember when they still had heat and it made it and it flew down. Essentially, that's what happened there. The thing was, this moth flew probably in one of their relays, and it short-circuited it, and it had a bug, and that was how the name came up. It's actually a name that was used in like the 1800s in different fields, but still, that's like the first actual computer-related bug we can think of, just simply because it was one of the first computers that was here, and it was found by the Americans, as everything was found by them. Anyway, no, we're not talking about moths, because I think if you need someone to take care of your moths, there's probably multiple companies here in New York that want to do this for you, I think. But sometimes I feel like pest control too when I'm debugging. To quote Edgar Deitzker, one of the greats, and not as great as James Gosling, who I actually met last year at Debuggers, and looked pretty tired, probably, with all these discussions about null pointers. Anyway, Edgar Deitzker once wrote, if debugging is the process of removing software bugs, then programming must be the process of putting them in. And we are doing here probably a lot of programming. And so we need to do a lot of debugging, because only if you don't write any code, or if you write it in Haskell, you don't have any bugs. Anyway, at least according to to one of my favorite XKCs.
It's true.
It's true, yeah. I've written Haskell code, and because it has no side effects, it didn't print anything, so I couldn't find any bugs. Anyway, I used to do exam questions for Haskell, which was pretty funny. Anyway, Java is what I'm currently working on. But anyway, check this code here. You probably all know the time when your manager was like, when managers were like, we should tell people to write this and that amount of lines of code because that's good. So consider you have such a manager and you want to count the lines of code that you've written in a project, then you write your own line counter, because you use something that's written by other people, so you write it yourself. And what you expect is that you call it on the same file, and it throws out 36 because that's kind of how much it took to write it. But what's actually happening is that it throws you a no such file exception, and don't look too closely on it. let's just look at the code. It's a demo application, but I think it's not so dissimilar to many bugs that you found in the wild. So essentially, we have a program that takes the arguments, switches over them, and checks, oh, is this a line? Is this a code line? Then calls the methods with different calls count code lines, calls count lines, and then it calls, returns the number printed, and that's fine. And it's pretty simple. Also here, count code lines just gets the amount of lines, and count code lines just checks for all the lines that don't have a slash in them or start with them, and where the line isn't blank. So it's a pretty simple measurement of lines. So there's a bug in it. So in normal cases, we would then use a debugger because, yeah, we can look at code, but essentially when our code is getting too big, like bigger than like the 36 line, it's usually helpful to use a tool for this. And when we go into it, we use here IntelliJ. We can set breakpoints somewhere at the beginning of the main method because there's where this happened around. And we can see it here, we can step over and we can see then here, okay, the file is code line, so we probably made a mistake here. So we can easily see, okay, that's a mistake. And in modern IDEs, we can even say, oh, but I know what the correct path would be. We set the value directly dynamically, making debugging far, far faster because we don't have to rerun the program at every tiny bug that we find. So yeah, that's all. I've shown you how to debug. Cool. No, that's not why I came here. So I have in the following a slide focus on IntelliJ. That doesn't mean that I don't like Eclipse. I used Eclipse myself in university because we had to. And IntelliJ, it has just the thing that I use IntelliJ for work, doing stuff, and I think it's a good IDE, but all my examples are also viable in Eclipse. And they even show a few things where Eclipse is better than IntelliJ, usage-wise. But anyway, someone from IntelliJ, Deferral, wrote like on the question why debug, he wrote to find and fix bugs. That's like the most obvious thing, but also to analyze the code. So what I usually do when I jump into a new project, I work in open source full time, I use the debugger to jump right in and check how the code behaves, what arguments a method is fed to see how a method behaves. And that's where a debugger will shine. And also we can use features like code modification, so we can change behavior on the fly, but we can also add more logging on the fly. We can use a full range of possibilities in modern debuggers, which is well nice, and I'll show you a lot of them in this following talk. And that's pretty cool. So debuggers are like really essential for this. So now it's time for me to ask you some questions. Any OpenJK developers here? Oh God, guess so. But still, if you find something not quite right, or if you have questions, just throw your question in. I think we have enough time to make this. Who have you used the debugger before? You think that's you didn't?
I did.
Yeah, you think that's a trick question. When I gave this talk first, I was in Darmstadt, a really nice user group if you're ever in Germany. I gave this talk there, and then someone didn't pull up his hand. I'm all like, why are you here? He was like, yeah, I'm with my father because I'm looking for a company where I could have an internship, because in Germany pupils need to have an internship, and like when they're like around 16 years old, and he looked for a 2-week internship at a company, and he thought like going to this talk would be fine. He didn't get that much out of it, but if some of you are in,
he didn't use the debugger.
No, he was like, he looked for an internship. So
okay.
and so still, it's not a talk about how to debug, or that there are other talks. I have a collection of resources at the end. There are a lot of resources for IntelliJ because they have people that do provide resources. They do create them full time. And there are also resources from Eclipse. Who of you has used it? Who of you debugged remotely before? Okay, cool. Half of you. Yeah, it's good to know my audience. It's just like, but it's every time I give this talk, it's the same, but it's still good to know. Sometimes you have an audience that doesn't know things, you can focus on it. But anyway, so I think as you probably guessed that as a developer, you have a toolbox. You have a toolbox where you put like debugging in, put like testing tools in. You also put like your profiling techniques on. So it's really important that you know your tools, that you know your mechanisms beforehand, that you use your techniques, and then when a problem arises, you can easily use these. I'm Johannes Bech. So who am I that I talk to you? I'm Johannes Bechberger. I usually give talks on Profile as well last year with this. I work at Submachine. Ta-da! I have stickers if you want with submarines on them. It's actually one of where I'm working on a team where we're the third largest contributors to the OpenJK. We're based at SAP. That's why the name Submachine comes from. So we're the third biggest contributor to the OpenJK, but we do quite a lot of other core projects. And I myself, I work usually on like profile front ends, profile back ends, and profiles themselves. So that's where my knowledge comes from. But I did a research project last year, or the year before. I'm not sure. I did a research project. Sorry, I did a research project like 1.5 years ago on the topic of debugging, and this where we learned too much about debugging and even fixed some bugs, but more in this later. So what we're going to do in the following is I told you about it. I gave you the introduction. That's cool. You know now why to debug, and yeah, that's hopefully self-explanatory. Then I show you about the architecture of debuggers and how like it works under the hood. Then tell you about remote and on-demand debug. And lastly, the main part is spent in the JWP and like the underlying protocol, and all the features that build on top of this. So strap in, it's just 170 more slides. So it'll be a fast ride. Anyway, for the general architecture, it's quite simple. The main problem is you want to have, when you have your IDE, for example, in this case, IntelliJ, but Eclipse is the same. This IDE has to communicate somehow with your JVM. So what IntelliJ does, it uses a Java API called the Java Debug interface to connect then via the JWP, the Java Debug Wire protocol, with the JWP agent that runs in the JVM. So the JDI runs on like the system on the JVM that IntelliJ belongs to, but the JWP agent is attached to the JVM, and this then uses so-called JVMTI, like essentially a C-based interface to connect to the JVM. And the cool thing is, when you don't like the JWP agent and everything that you see here, you can just write your own. But you shouldn't, because it takes quite a lot of work. And I can tell you from personal experience that debugging a debugger with a debugger crushes your mind. Because when you debug a debugger, then you're like, where is the bug? Is it in my debugger debugging the debugger, or my debugger debugging the debugger that debugs the debugging debugger? Anyway, holy rhymes. Anyway, so now that the thing is, that's all called the Java Platform Debug Architecture. That's pretty standard. That was here like almost, that's here almost as long as I am on this earth. But that just means that I'm slightly older than the JVM itself. But how does VS Code work? Any guesses? So VS Code is written not in Java, sadly, but it's written in some language that I won't name here. That is only called. I was once at a conference in my hometown, and someone introduced me as, this is the guy, he works on Java. It's something like JavaScript. And I'm like, Anyway, any guesses how VS Code can connect to your JVM? Any ideas? Uses ancient technologies. It uses a new protocol called the Debugger adapter protocol, which is really nice because like modern and chase based and everything. And that connects then to the Java debug server, which uses Java. Any guesses what this is based on? The Java debug server, because they didn't implement it from scratch because it would be far too expensive. And I show you later why. Any guesses where the Java debug server is based on? No, it's based on Eclipse. So essentially, every one of these cool kids who's running VS Code and is like, yay, it's essentially running Eclipse under the hood. So it's so I'll tell this to the young kid. No, it's essentially they had a problem. They had a problem that they wanted VS Code. It has its own adapter protocol, but they wanted to use Java. And you couldn't use this. You couldn't do this with IntelliJ because IntelliJ is too monolithic. But with Eclipse, they just essentially pulled out all the debugger parts without the UI, put it into a nice little server, put the protocols on, and it works, and that's pretty cool. And that means that Eclipse will live forever in the Java world. Anyway, now we're further on to remote. I showed you how like the rough architecture works. Now just some tidbits, some tiny things. About remote debugging, it's fairly simple. You just tell your IDE I want to do this, and it tells you here. That's like the command line arguments that you have to parse. You essentially configure the JWP agent properly, and you pass this a few things. For example, you parse the address here, and you tell it better to suspend your JVM while it waits that the IDE connects and more. Has anyone seen any issues with like address equals star colon 5005?
No. Star.
Yeah, the star is not great because it means that your JVM accepts incoming connections from every system, and usually that shouldn't be because you potentially have a problem there. So just put in the IP address of your system that wants to connect to this. Makes it slightly safer. Any guesses? Who of you thinks that there are differences between remote and non-remote debugging? Just related to like the JVM and how the debugging works. Who of you thinks that there are differences? It's a trick question. You responded correctly. Of course, there's none. There's no difference, and you can even see it when you click on like in IntelliJ on the console when you normally debug. You see here that you pass here the JWP agent. The only thing is that it says, oh, it's a localhost, and it puts in a new port that it created. So there's really no difference. Both use on normal systems, just the underlying architecture that I showed you before. And that's cool. That means that it doesn't really matter whether you debug a remote system or local system. Of course, it matters kind of because you'll see later that latency might be an issue in some cases. So in the following, a few little known gems that I didn't knew about before I worked on this. For example, on-demand debugging. The idea was, and this was really nice for a couple of years, was that you could enable on-demand debug, that you can enable the debugging via J-command. You could say, oh, please start only like listening to debugging connections when you told it so via J-command. That was well nice, and it saves some issues. The other thing what was cool was on exception debugging that still works today, and it's pretty cool because you essentially can tell it, oh, every time there's an exception, for example, every time or the first time there's an exception, for example, the first time an exception X or I don't know, no such file is thrown, please then start the debugger, and that's pretty decent. You can even tell like, oh, the debug executable is this script, and so I can actually start a debugging session because you can easily debug from command line via JDB. So there are multiple options here. For the JWP agent, you can pass on timeout. You can include virtual threads or not. It depends on how on whether they're important. But virtual threads are like a sticky issue for debuggers, because essentially every time a thread is created, an event is created that like is sent over the wire. But when you have really many Loom threads, this can be a problem. This can be a performance issue, but people are working on this. And yeah, so what's also interesting that you can tell your JWP agent, please listen for incoming connections or connect to an IP address outside. That's nice when you have firewalls that prevent incoming connections. And yeah, before like in the olden days, there was also different transport modes, so you could have like not via sockets, but also via shared memory, but this was only supported on Windows and essentially rotted away because nobody used it. Who uses Windows anyway? I'm in profiling, so we're like with the newest features. So hopefully in 1 or 2 Java versions, you will have a proper CPU type profiler. And we decided right away that we don't care about Mac or Windows, because nobody will profile it on these machines. Anyway, that's the thing that you have to be aware of. You have to think where like the majority of customers running their code, and these are the platforms that are best supported. And for example, the best support in the Java, you should usually get it on Linux, just because we as JVM developers, we target these. So Amazon is a big contributor. They are probably running quite a lot of JVMs on Linux machines, and also SAP runs quite a lot on Linux machines. Therefore, just be aware that Linux is the best platform. That Linux sometimes has advantages. Anyway, but let's go. Let me take you on a short journey. Usually, all my journeys start at night because I usually get up at 4 to get on a train station. That's my local train station. I live in Karlsruhe. It's like south of Frankfurt, and for this, I took the train up through Frankfurt to Debuggers, Belgium, and Netherlands, and had some nice stickers with me, and put them everywhere in Antwerp. And they have a real nice train station, and I met some people that were loosely related with Java, if anyone knows them. And one of them almost got into a toilet bowl because the toilet bowl at this restaurant was closed. Anyway, it was really funny because But what I want to show you is that I found, while I was on the train there, I found a bug. It was like, I was looking into this bug at the corrector booth, but it's and if you look closely, it was shipyleft. So essentially, I had nothing to do with that explosion. So I stood at the booth of corrector and was like, "Can you help me with this bug? It's really bug." And it's even the picture there that it took from Twitter. And it was a mysterious bug. But it wasn't this bug, so maybe you can see that was a bug that hopped onto my a ladybug that hopped onto my luggage while I was in Antwerp. The problem was I didn't have time to get it off, so it traveled to Cologne. So anyway, well, I can tell us grandkids about this long journey. But what I actually found was this. So and that also shows you that there are still bugs in modern debuggers. So I found them. I use JDB, like the command line debugger, just because IntelliJ would just break off any debugging session. Because as you see here, there's a null pointer exception in the debugger. And that's really interesting, and I wondered why. It was related to this feature on exception and on throw that I told you before when you told it like, please start a debugging session whenever an exception like no such file exception was thrown the first time, and it caused a null pointer exception, which was not great because the feature was thereby unusable. So I looked into this, and that's kind of my job because I work on OpenJDK, so I found a bug and I fixed it, and now it works. But I can tell you, fixing bugs in a debugger because the debugger ran in Java, so I had to run the Java debugger and a different debugger to fix then the null pointer exception that happened in the debugger, and then simultaneously run some GDB on the OpenJDK. I can tell you that's not good for your mental health. So if you ever are in this position, keep it to the professionals. We at OpenJDK, we fix these bugs. That's the reason why people pay us, so that they don't have to do this. But yeah, it was a nice, interesting bug, but now it works. I backported it to all the JDK versions before, so you can use this feature in only in JDK 21 and 17 in every current like major version or LTS version. And now it works, so it's a pretty nice feature. You can even use it with IntelliJ or Eclipse, because now it doesn't it doesn't throw a null pointer exception anymore. So yeah, that's what I do. I sometimes fix bugs in debuggers, and yeah. So anyway, we now got from the interesting part and still have 160 slides left. So let's start. Essentially, what we're talking about now is about this part, about red file. Like, how do we get from like our JVM that runs like our IDE back to the JVM that runs like our application? And what's really instrumental is the JDWP protocol. It's like a protocol that's now around 25 years or more old. It's like from 1998, I suppose. And that's the basic structure. So in these olden days, nobody knew about JavaScript, so nobody knew about JSON. So we had a simple protocol that was so simple that you had to read, that you had to see all the packets that came before to pass the current packet, which is really nice when you want to parse these packets. Anyway, so essentially what you have here, you have requests that your IDE sends to your JWP agent. They have things like a length from IP and such, and also a command. So I request, the IDE requests something to JVM, but the other way around is also possible, like an event comes back. And then the IDE would, the JWP agent would reply by a reply package. And that's a pretty simple protocol. Now, there are a lot of these. So the cool thing is there are thousands of these packages for even the most simple things. And so what we're going to see in the following is like how it goes from starting a debugging session to the first suspend. We set a breakpoint at a certain point in the program, so we're getting so we're checking what messages are going over there. So you can probably just feel how many packers are there. I'm not starting a demo now because it's brittle and I think it won't add something here, but essentially I'm telling you now how to start it. So an important thing here that I forgot to tell you is that what the main idea here is, and you have to keep this in mind, is that you have two states of information. You have two bases of information. You have on the one hand the JVM that knows everything about the program because it runs the code, and then you have your IDE, and your IDE kind of knows a lot about the program because it might have the sources, but especially when you have a command line debugger like JDB doesn't know anything about your program. You might not even have the sources, especially for many libraries, you don't have the sources usually. So the idea is essentially that you have these 2 points, and they want to share knowledge, and it's really important because the IDE has to know all the things that your JVM knows in order to fulfill. And so we're here in New York, so I didn't put a picture on, but I think you can picture yourself. You can picture yourself down there on the street, some cars vendor, just like food vendor. So maybe you know Mark Twain's novel A Yankee at King Arthur's Court. Cool. So essentially, the plot in this novel and the plot that I'll be like sharing with you, is consider you're not a Yankee that was dropped like at King Arthur's Court, but consider you now fall asleep and then wake up down there at your own stall, and you haven't cooked before and you haven't done anything before, but you're like, what am I doing here? But you know someone, you have a telephone joker. So consider now you have a telephone joker and be like calling home mom because she's a good cook. So you're calling home and be like, I have a problem. Can you help me? And essentially what your mom needs to know, like mom needs to know where are you and who are you? So needs to do a handshake, be like, are you Hannes? Yeah, I am. Cool. Then what your mom also want to know, so hey, did you start the car? Like, are you currently standing there? And you're like, yeah, cool. Send it back. That's what the JVM also does. It says, oh, it started. And then maybe it's important for the person that helps you to know, like, what's this car and like how large is this car? So in this example, so what are we talking about? Here in this example in the Java world, you have like IDEs, so it's just some basic stuff that the protocol needs to function because it's not hard coded. And then your mom tells you, like, whenever a new customer comes and whenever something changes, please tell me. That's really important. So Debugger also tells the JVM, like, whenever like a new class is prepared, please tell me, because as your mom, your debugger needs to know when the state changes. So both have the same information here. And then your mom was like, so, okay, what card are you running? Is this like a Samosa card? Is this like a halal food card? So that's fine. Tell it. Debugger asks like, hey, what version are you? And what capabilities of do you have? Is it like a card with a crawl, with a threads, with anything? Cool. It's also like, and because your mom wants to be sure, she asks also for new capabilities because you're an old person now with Java 1.4. And then you look around, tell her everything you know, tell her everything like, oh, there's a queue of customers there, there's the food here, so you have a state. And give more information. Then whenever something changes, before you call back. And then something happens. For example, a new customer comes in, and you're like, "Haha, mom told me I should phone her back." So you phone her back and be like, "I have a problem now. The customer wants, I don't know, wants falafel." And it goes further and further, and that's essentially how it works, because your JVM and your debugger, they need to share knowledge, and the further it progresses, the more knowledge is transferred from your JVM to the debugger, and this is all knowledge that you need to debug. And it's essentially the same in our story, that your mom does nothing. She doesn't know, he knows who you are because I told her at the beginning and she's your mom, but so she doesn't know anything, but you can probably picture in the situation that the further you go, the further she got enough knowledge to help you with this, to help you kind of debug the situation, this mess you got in. And now this is where my metaphor breaks down, but I think you probably get the picture here. And this doesn't mean that I only had like 2 bagels today. I'm slightly hungry. Anyway, but the bagels here are good.
New York.
But they're also not as good bagels, but you have good bagels. If you're ever in Kansas City, Sugar Bagels is the only place to go. It's not far away from the city center. Go there. And when you are in Montreal, don't ask people which of the two bakery companies they like more. It's like a cultural fight, I can tell you. But go to both, and then everyone is happy. Anyway, so essentially in our example here, with the JVM, our JVM needs to load classes, so it needs kind of a file loader that's like what's typically used. And for every loaded class, the class identified with an ID. You also tell which kind, is this an interface, is this a class, is this an enum, and also like the signature, essentially the name, but the name isn't enough because usually classes have more than just a name. Many of them have, for example, some kind of properties like final things, and they also have generic signatures, like they have generic type parameters on them. Anyway, then fine, we loaded the class loader. And then your JVM tells it, so yeah, I'm loading now different classes. For example, here I prepared the line counter class because it's our main class in our example. And then your debugger wants to know information, like your mom does with the code. It needs to know everything. How big are the scallions? How big is these and that? And essentially, that's what you do here too. The debugger asks, "Hey, give me please the line. Give me please all the methods of the class, and please give me also the line total in the method." Because the thing is that your JVM deals with bytecode in the end, because that's what the JVM deals with. But it also but you as a user, you much rather deal with line numbers, because if I tell you, oh, it's at bytecode index 200, you're more likely to get something out of when on your IDE gets something out of when you know, oh, it's at line 10. So that's what we're getting here. We're getting these tables. Then you also, the debugger also asks, hey, what's the source file name? So it can use this to maybe check, oh, I have this source file already there, and lots of things more. For example, it also gets to know like which type of class, which type of file it is. For example, debugger asks it, hey, is this something related to colon or Java? What's like essentially the file ending? And there's a specific command for this. And it asks for many, many more things, for like 1,000 requests or more. And then, we want to start, of course, doing something interesting. So we set a breakpoint, and the debugger then tells the JVM, please set a breakpoint in this specific method, because we obtained all the method IDs before, so we can reference the method at this specific bytecode, and then call me back, please. So the cool thing is the JVM supports breakpoints, but not, so it knows, the JVM knows intrinsically and can easily work with breakpoints. It essentially uses parsed mechanisms, so that's cool. Does anyone know a runtime or language runtime that doesn't support breakpoints out of the box?
Fourth.
I'm talking about used languages. If you come with COBOL, then like that's not a runtime. I think Forth is usually also compiled. I'm talking about like language runtimes for languages that I kind of interpret. Any more guesses? Anyone of you heard of Python? It's you heard it's like a language that a few people use and I sometimes don't know why. So Python lower than 3.12 was really messed with breakpoints. Python starting at 3.12 is slightly better, not only slightly. So if you want to know more, I've written a 4-part blog series on this topic. So yeah, you can check it out. That's also the only reason why I'm at Python conferences, just to tell people how to write debuggers from scratch. Because actually last year when I was between two conferences, like after Java, so fall was nice, but lying there on the couch at a friend's house, he was writing some Python, but I was like, I don't want to work on this talk that I promised to a conference, so I worked on Python. Because it seemed to be much easier, but in the end, I found out that Python lacks some things. So Python might be the cool kid on the block, but they don't have features that like the JVM has for over 20 years, which is kind of weird. Maybe they get like support for breakpoints in the future, but maybe not. Anyway, we're going further. The debugger now set everything up, knows all the information, but now the program has to execute, because if we don't execute the program, we can't find the bug. So the debugger tells the JVM, please resume. So please start the program. And then the JVM is like, oh, I hit breakpoints after a while because we set a breakpoint. It hopefully hits it sometimes. So we hit a breakpoint and it's like, hey, I hit this breakpoint and it's related to this set breakpoint request and it's in this specific thread. And at that specific location, essentially at this bytecode location in this method. And that's pretty cool, because then the debugger can show in the UI, oh, there's where breakpoint currently happened or currently hit. So and then the debugger is like, oh, I need to get all the information that it can get at this point, because essentially what debugger tries now, it tries to show you it tries to get all the information it shows you at the bottom panel, like the current frames, the current local variables, and much more. And then the debugger tells the JVM resume, everything goes to plan, and JVM dies, and it sends at the end a frantic VM death event. That's how the VM dies. And there, but here are many more than these few commands they're showing you available. There are around like 95 when I looked into JK20. So there's quite a lot of things to look into. But does the JVM has to die? So we saw here, okay, our debugging session essentially ends with the JVM dying, but has this to be? So framed differently, who kills the JVM? It either dies on its own, so someone called system.exit, or it just run out, and that's fine. But there's also a possibility that the debugger tells the JVM, hey, please, just exit. That's fine. But can we reattach debugger then? So is it possible for us to close our debugging session and then reattach? And yeah, that's possible. In Eclipse, it's fairly easy to see. You have two buttons here. You have the terminate button, which sends the exit signal. But you also have a disconnect button. What it does, it disconnects the debugging session, and then you can reattach, which is really, really nice. The problem is here with IntelliJ, the UI is a bit messy. I only see like a stop button that disables all. But I can also disconnect. I have to click on this little X there, which closes this, and then it has a pop-up which tells me, what do you want to do, disconnect and terminate. It's not the best UI decision, especially what happens when you say don't ask again, then you have to go to the settings menu to re-enable. I know, so that's one of the cases where Eclipse has a far, far better UI. Maybe I should start using Eclipse again.
No.
Why not? You're an intelligent. Are you paid by big JetBrains?
I don't care about IntelliJ. I just don't want to put Eclipse.
Yeah. I use NetBeans. I used NetBeans before, but NetBeans is sadly like not there anymore. Yeah. It's so sad. I used NetBeans before, and I'm like, oh gosh, they had such nice UI. They had an integrated profile. Everything was fine, but now it dies, and it's like, nah. And I tried to use VS Code for Java debugging. I can tell you, it's could be better. Anyway, now onto some more interesting stuff than thinking about NetBeans. Sad thoughts. Onto conditional breakpoints, which are slightly less depressing. So how conditional breakpoints works is quite easy. For example, here we are in our count code lines method that probably has a bug in there. So with this com plus plus thing, we just told, okay, we saw a problem with like maybe it doesn't work that well. So we check for lines that contain the slash here. So how we do this in IntelliJ and Eclipse works the same, is that we can tell it, oh, give it a condition, and it's an arbitrary Java expression, and we can just tell it here, and yeah. Anyone had some performance problems with? Cool. Any guesses why? Does the JVM have?
I'm thinking that this test is done on the debugger on the other side of the network connection.
Of course it is. So as someone in the audience already mentioned, it's mainly a problem when you are when you go over the wire, when you go over the network, when there's latency in play. But yeah, the JVM has no support for conditional breakpoints, or has it? So with breakpoints, you can look it up. That's like it's looking like no, you can look into the specification, and there's like, okay, for breakpoints there are some configuration options, and one of them is case conditional. So one modificator you can have for breakpoint, you can have different options here, and when it is two, you can pass it an expression ID, and it tells you for the future, and the future is now, but it wasn't implemented like for over 25 years, so maybe they should remove it sometime, because it was in the olden days where like the JVM still had only a single language. It was just support for Java. But nowadays, the problem is when you have Kotlin, when you have Scala, when you have Groovy, the JVM would have to know all these languages. So that's not as great. So it kind of makes sense that there is no support. But still, it's a mess, and I show you now how. Essentially, how it works, how we still get conditional breakpoints is we emulate them by breakpoints in evaluation. So let's see here the example from before. We have this conditional breakpoint, and the condition is line that contains slash slash. So essentially, we have our code file that has a comment at the beginning after like all the imports, and we check for it. So I don't show you the handshake and everything now again, because you probably noticed that it's quite repetitive. It happens the same every time. But essentially, what our JVM does now, what our debugger does now, it sets a breakpoint at the specific location. That's fine. We don't use the for the future features. We just set a breakpoint here, and how it works now. The JVM is suspended because the breakpoint was hit, and then the debugger asks like, "Hey, give me the value of the line, like, give me the string here." And JVM is like, "Oh, it's import java.io exception." Then the debugger is like, "Please create me this string with slash slash." So you have the string on your heap. JVM is like, "Here, I get you the string reference." Then debugger is like, "I don't know which method string has, because like maybe your string has different methods. I don't know. Java can sometimes be weird." So the JVM is like, "Here are the method references and the names." And then debugger is like to JVM, "Hey, please invoke the contains method on this string I give you here in the string reference, and on the slash slash." And the JVM is like, "Yeah, it's false." And the debugger is like, God, do it again. Okay, resumes. It suspends. It invokes the method again. And then it finally gets to a value of the line where this is the case, and where it returns to. The cool thing is this works only because Java is platform independent. Only because the JVM on your machine has the same execution semantic as the JVM on the different system. Essentially, this debugger here evaluates all things like plus and minus, and is something true, is something false on your machine. and not on a remote system. So for example, if you have a conditional breakpoint that checks whether 1 equals 2 or something, then that's still evaluated on your system. But every time you either create a new instance or you call a method, which is, or you call a method, then this is referred back to the JVM. And yeah, it's not as efficient as you might think, because you have many round trips. And yeah, now when we are at this location and we finally got it, we get all the information as before to show it. So this also explains the breakpoint option. So if you wondered why you have like what to suspend all or the thread, that's actually an option in like the breakpoint command. You also can enable or disable. So for example, no, you can also suspend or not suspend. That just means, oh yeah, we don't call suspend on this. We resume directly. You can enable disable. This just means add the breakpoint or not. And you can even have more things like evaluate this specific expression, because every time we're at the breakpoint, we can, of course, do the same. We can evaluate all expressions, lock them, do something else. And that's pretty powerful, but also slow. So that's what you get for the power. That's the same, by the way, in Eclipse. Just the UI is slightly different for conditional breakpoints. It takes you a few more steps to do this. So any guesses how watches, eval expression or so are implemented? Any guesses? Anyone? Anyone still awake? Any ideas how you could implement, knowing this, how you could implement like eval expression like this?
I'm guessing reflection.
No, it's the same.
Okay.
You use it. It's essentially the same thing. So whenever you do an eval, you're doing the same thing that you do when you do a conditional breakpoint. It makes sense. You essentially have a Java. You essentially then have a Java interpreter in every debug, and that's the reason why with VS Code you use an Eclipse-based debugger under the hood, just because you don't want to re-implement this.
I think this could be just me noticing it, but I've seen the expression evaluator is quicker than the actual evaluation that happens. Like it becomes really slow, but this evaluator, the expression evaluator, it's really quick.
Oh yeah, there should, on the technical side there isn't a difference, but of course with the conditional breakpoint that's evaluated quite a lot of times, especially when you have it in loop. But it's literally the same code that runs on the hood, and these are literally the same commands running over the command line. So the reasons, so some reasons for this is just like that. The underlying API is a terrible API. We should get rid of it as much as possible. It was said to me by an anonymous Java architect that I met at Debuggers Belgium. There aren't that many, but I think many of the Java architects would like saying this. But anyway, the underlying APIs are not the best APIs, but we have them now. And the problem is they are not battle tested, and they work. So yeah, we could implement new APIs, but with all the bugs it has, all the tool developers just essentially assume know the behavior that it has. So changes to the API are pretty hard. Conditional breakpoints are really complex. So they're complex to implement. So they are slow, especially with large conditions. And any ideas of improvement? So if you could make it simple, if you could control both the IDE and the JVM. One, oh yeah.
There's a lot of I think from your presentation, I feel there's a lot of back and forth going on between debugger and JVM. If there's some way it could like merge together or be faster, I think that would improve.
That's essentially what I did. So that's why I looked into this. It was eventually a failed attempt, but I came up with an approach, and they call it like the JWP tunnel. So when you have a debugger on the one side, and then the large internet, large cloud, and then on the other side you have your application running somewhere. Then usually when your debugger asks for the values x and y, just it first asks for x, gets x, gets back, asks for y, gets back, and that's not the best thing to do because it's a protocol that has some synchronicity in it and gets even worse with like conditional breakpoints. So my idea was, why not just add kind of mirrors in there, add like a tunnel in there where I know whenever the debugger asks for the value x, I know from beforehand, okay, the debugger will probably ask the next time for y, so why not ask both together? So we reduce the amount of messages to and from, and thereby reducing the amount of latency introduced. It was a nice idea. The main problem was it's really hard to make it run reliably because debugging is highly asynchronous. You have on the one hand requests coming in, on the other hand having events on, and the order is important. So I tried to debug this for like a month or two, and they still had issues, missing packages, and so I'm like, screw it. That was like a failed attempt. I spent like 3 months on it. Yeah, sadly didn't get out anything, but I'm grateful to my team that I could work on this, and I could do some research. All the code is online. You can look it up. You can use it to log your JWP messages. There's too much code lying in there. Even did like code synthesis. So for example, what I did was that they split the JWP requests and the requests coming in that the debugger was sending. I split them into packages that were like kind of self-contained and didn't have any side effects. So I could then generate debugging programs with it, could generate like simple things like switch case, loops, recursion out of this, and essentially synthesize debugging programs. It was real nice. It reminded me of my PhD times. I tried to do PhD for 2.5 years in the field of compilers. It was really nice. The only problem was it didn't work at the end because it was too complex. So I switched into profiling after that. So one of the reasons is also why I did it was that eventually I found that it isn't probably worth it for the gain that we're getting, because when you really have problems with latency, just use the debugger protocol. Just use essentially VS Code. Because the cool thing with the debug adapter protocol is it supports conditions. You can just give it a condition and that's what it says. So the ideas here that you place your Java debug server close to your application, for example, directly into your cloud server, and you place your VS Code is essentially on your side. So over the cloud is only going, over the internet is only going the debug adapter protocol, which is fairly simple and where we essentially alleviate the problems. So this is one of the reasons why I didn't work on it. Implementing the debug adapter protocol directly in a JWP agent was also an idea that I had. The main problem was far too complex. Was far too complex. So for the time being, when you want to use debugging and want to have like it over the wire with like less latency, just use the debug adapter protocol on VS Code. Hopefully, IntelliJ supports in the future also the DAP. Well, let's see. Any questions till now? Yay.
I got questions. You know I would have questions. Couple of questions. The first one's kind of simple. I'm running a 32-bit Java on my production server because I don't have to spend as much for the cloud memory, and I don't need 64-bit. Is there a problem No,
a debugger. So the cool thing,
they're going from a 64-bit client running an IntelliJ connecting to.
there's no problem. The cool thing is that I showed you in the beginning that when you start your debugger, the debugger gets from the JVM, hey, how large are my IDs? Because the field
I
IDs,
saw that,
they
yeah.
essentially point us. So usually it's 8, yes, because we're on 64-bit machines. But when your JVM runs on a 32-bit machine, it returns 4, and so there shouldn't be any problems.
Cool. Second question is a little harder. I've got my paranoid hat on for this question. And yes, when I use remote debugging, I specify the IP address I'm coming through, which reduces a lot of security issues. But if, for example, I'm debugging and I print out a user password that's not going through an SSH encrypted tunnel, that's clear text, is it not?
But you found the solution already. Just use an SSH tunnel, of course. Who connects to a sensitive server directly via plain text protocol?
Well, how do I do that? I'd like you to explain how
Okay, you can just set up a tunnel from your remote system. Just have an SSH tunnel.
Okay, and just do that. Okay.
And just do this and run the protocol through this. This protocol was developed in a time where nobody cared about security.
So I
remember it was developed in like 1996 or so, or 1995. I don't know. Like, I know Java was developed, I think, in 1996, but it was around this time where they developed it, and so this was a time where nobody cared about security because nobody had computers. The printers were sell these like with these like things. You had to when your mother got on the telephone, your internet broke down because there was only one connection. I grew up in this time. I'm not this young. Anyway, yeah, just use an SSH connection.
okay.
The protocol is arcane. And nobody ever thought about encrypting, because also you have the problem that usually you debug on your local system, and there it makes sense. Of course, be aware that on your local system, please don't open all the ports that JWP uses by standard, because else someone else from outside can connect you to your system because you open the port. So be aware. I'm not a security expert. Talk to the experts. Good. Any more questions till now?
I have a different problem. I have a different problem. I'm curious because I know I work on Scala and Scala uses JVM, and Scala also has a concept of implicit, which is like something magically appears in the compiler and doing something. Do you like do you know how it works? I mean, I'm sure.
I don't know. I have a friend who works on the who works on the Scala plugin in IntelliJ, but yeah, apparently developing IDE support for Scala is an interesting topic. And so, but the thing is, you have to keep in mind that the JVM is agnostic to the language that you're using, and everything you saw is just the JVM cares about the bytecode. It doesn't care about line numbers. It's just bytecode, and all the line number table that it has, that's just additional debug information. That's like metadata that's put into the class file. So from the JVM perspective, it doesn't really matter which language you use. The only problem with Scala is that it has lots of tiny allocations, and yeah, garbage collector like it, and the JIT also likes it. Yeah, I hope it kind of answered. I'm not knowledgeable in Scala. I tried it once, and then I saw how many implicits there were, and it's like, that's too much magic.
Well, the good thing is that they are going away after Scala 3.
They
That's what
are-
I heard.
Yeah, so the cool thing is when you are here in this Java, most of you are probably Java developers, so Java is incrementally getting slightly better every like 10 years. The problem with Scala is every 10 years they're like, let's rewrite this. We had a new, they have like a new PhD group in there because the old one's like finished. That's, and then they're like, let's redevelop. And you have in the Scala world, you have the division about between people that are like researchers. I like researching. That's really cool. Doing a PhD thesis on like something Scala is probably totally awesome. You have the people that are like, we want to do research. It's cool out here. And then you have the people like probably you that want to use this language to do something practical. Maybe use it in the Spark context. That's where I know many people use it. And there's this division, and they want like stable APIs. They want a stable language, and not a language that like changes every 10 years completely. And these people want to do this because they're like PhDs, and after 5 years they need to have enough papers for their PhD thesis. And so there's a slight division. So that's also a problem, of course, in the JVM world, because a slight problem because nobody in the JVM will like focus their attention on Scala, on making Scala fast, bytecoded Scala C produced, because you make them fast and you make something fast for Scala, and then Scala changes a lot because it takes like a couple of years till change gets really rolled out to production, and then Scala changes a lot, and then you're like, oh, and was it worth it? So yeah, that's my 10 cents on Scala. Use it when you like, but I usually use Java or Kotlin, and that's what many do. Because I like, and sometimes I use C and C++ because the JVM is developed in C++. So I'm a Java developer that uses C++ a lot. All other people are just Java users. Anyway, that's why it's called Java user group. Anyway, on to my slides. So an idea on how to make it better is just extract the whole thing in a method. So especially when it becomes large, it's helpful when you extract it in a method. The thing is that this method is then like directly run into your JVM, run in JVM, potentially also like potentially also JIT compiled, so it's far faster. And you can even use, like when you change in this method, you can use hot swap. Hot swap is essentially you recompile a class file, you reload it in the JVM, and this works if you don't change any method signature or add new instance fields, but you can change the content of methods freely. That's pretty nice. Yeah, or add a condition to the code. That's what I usually do. It just add a condition here, set the breakpoint there. That works also quite nicely. Yeah. Now, any IDEs here? So, who of you thinks that methods with breakpoints are interpreted? With interpreted mean slowly executed. Who of you thinks this? Who of you thinks they are just JIT compiled if you set a breakpoint in there? Okay, nobody. All confused. Yeah, they are de-optimized. So that's a real problem. When you set a breakpoint somewhere, the time you set it in, the method is de-optimized because debugging only works probably on interpreted methods, and that might be a problem. So be aware that when you put your breakpoint in a hot loop, that might be problematic. And if you don't trust me, I've printed here the link to the Java version, to the code cache file. It's online 1425 in probably a slightly older Java version. So when there's save points, so essentially a mechanism for Java to synchronize all the threads at a certain time and point in time, and to have all threads waiting, and then Java can do things. For example, do garbage collections to detect all threads. And the interesting thing is, save points are also used in debugging. So signal stepping is implemented using save points. I didn't know this before. It's just interesting. The interesting thing is also that, of course, when a method is signal stepped, it's also de-optimized, because signal stepping can be seen as just placing quite a lot of breakpoints in there. Any guesses how many resources there are on the topic of how debugging works under the hood? Anyone? Anyone a number? 10? 10 to the world. Yeah, that's not that. I don't count this because when I made this talk, there wasn't a start. There's none, but there's like one from there's no resource out there how it works on the hood. But there's a resource from Apache Harmony, and for those of you who don't know, like that's like Apache Harmony that the older people in the room know, the newer ones not. So it was the good old times when Apache people like it's probably Eclipse related when they tried to re-implement everything in Java in like Apache 2.0 license because the OpenJK is GPL license and I don't know what the license terms were at the time, but essentially they want to have it in the Apache project. The only problem is it didn't went that well, so they cut the project in 2011. But they have the only resource on the topic, yay! And it's still kind of accurate, and that's interesting how it doesn't change that much between the years because when you're in JVM world, the changes are quite subtle. There are, for one, not that many people working on JK. So there are probably like less than 100 people working full time on the JK. And also, even they usually spend the time with fixing bugs. So a lot of the time is spent of optimizing it a little bit, but whole rewrites don't happen that much. That's why it took so long to, for example, implement Project Loom and other newer, cooler projects, because it's quite a lot of effort and you don't want to debug these. I have a colleague who implemented Project Loom on PowerPC, and he worked on this stuff for like almost a year. So it's quite a lot of fun. And we're also now supporting IX, so that's also quite interesting. But no, it's the thing is that it was so funny. You probably all know SDK Man, with which you like switch between SDKs. Another problem I was running on PowerPC, and I used SDK Man as I always do, and checked like, oh, I want to get this JVM, and it downloaded me a JVM, and I'm like, cool, fine. It didn't report an error because it didn't know platform, so it probably knows the platform, and so that was not great because it downloaded an x86 binary for like 64-bit Intel binary, and then the JVM crashed because like the computer didn't know what to do with this binary. And so I was writing to the people in the SDK man Slack being like, hey, you don't have support for PowerPC, but could you at least give a warning when someone runs PowerPC? And they were like, who in the world is using PowerPC? And I'm like, there's a small, tiny little company here, like biggest IT company in Europe that has enough clients on PowerPC. Please, people that need to do work. So it was quite funny. But anyway, I got it fixed. So nowadays SDK man just complains. But yeah, I helped implement the PowerPC features in async profile. So worked on this a little bit. So anyway, now for the last few minutes of my talk, I give you a rundown on more IDE features and how they implement using JWP. There's of course hot swap. I've shown you before. It's very simple. So we essentially recompile our code, and then in certain cases where we didn't change that much, when we only changed the method bodies, the IDE asks us, hey, do you want to reload? And how this works is that the debugger just tells the JVM, please redefine these classes here as bytecode, please. And then the JVM is like, okay, cool, I'm done. And debugger's like, hey, please give me all the methods, fields, and everything as before. Then set a specific value. It's also not that hard because we're again in our introduction example, and we know, okay, file is not great, but we don't want to run this again, restart it again, because essentially it would maybe mean a more complex example that we have to run through a lot of hoops or do some setup stuff. So what we can do, we can tell our IDE, hey, please set a value, and here we can put any expression, And how it's implemented like we did with conditional breakpoints. So we get the methods of path, we get the value of ours, get the value of ours at position 1, and then compute it. And yeah, and then we can set it essentially, we first get the visible classes because we need to know which classes are visible, which we can access here. Get the value of ours, get the methods of path, and just set the stack value. That's quite easy. There's also force return, which is quite nice. So we can force return from a method. For example, here we can force return with a value. Yeah, the expression is as before, slowly implemented using the interpreter approach. But returning means that we then jump back up. And there's also okay, interesting. And because there's also a command called force early return request, and it works. The interesting part is here, consider you're in this code. You and you have a code with like exceptions and everything, and you have a finalized block. When we set a breakpoint, for example, here on the throw new x, and then we prematurely return, who of you thinks that a finalized block is executed? Okay, who of you thinks that it isn't? Interesting audience. So no, it isn't. So if you look closely into the implementation here, into the JWP spec, you see it written as no further instructions are executed in the code method. Specifically, finally blocks are not executed. Therefore, use force return with care. Use it only if you don't have any finally blocks, or especially if you aren't like in a tribe with resources, because then you have resources open. This might lead to issues. Just be aware of this. So use it with care. There's also the reset frame that I like to use a lot. You essentially can reset the frame and can restart calling this method. This essentially is great when your method doesn't change any global state, doesn't change real much. It just computes some value, given some inputs. You can then just set, oh, reset the frame, and then the next time you step into, you re-evaluate this method. And the command is pretty simple. It's pop frames. It's essentially pop the topmost stack frames from the stack. Then there's throw exception, so we can throw an exception. That's also pretty easy. We create runtime. We create in this instance an exception instance, and we then tell, hey, JVM, hey, please stop, but with a specific variable in specific thread. And the thing is, to conclude here, to come to an end, the whole protocol, it's a cane, but it's better than Python, usually fast enough. And yeah, so if you want to know more about Python, I did it there too. But still, it has its advantages and disadvantages. The cool thing with the protocol is it works. So it's there. It worked for 25 years. It will probably work the next 20 years, hopefully. So it's on this really versatile. You saw it's like it has almost 100 different commands. You can do quite a lot. So keep in mind that it's just one of learning how to debug, and understanding how debugging works is just one of the things that you should have in your toolbox when you have a problem like testing and profiling. And always remember, say no to complex breakpoints and keep away from excessive debugging and remote debugging. That was actually a propaganda poster from the Soviets, where they were saying no to alcohol, but they found it so nice to have it here. So it's not AI generated; it's just generated by some Russian, by some Soviets. But I found it quite fitting. But because really, please keep away from complex breakpoints. They are such a mess. You get so much in trouble, especially if your breakpoint conditions are large. It's fine if you're just running like a tiny program, but if your application gets larger, I showed you how to deal with this. please look into this. And also, like, single stepping is a problem. It de-optimizes every method that you step in. So if you step a lot, then your program also got slower. Just at breakpoints at specific locations afterwards. And yeah, remote debugging, especially with complex breakpoints, is not a good idea. Just don't do it. Much rather use like something like VS Code with the debug adapter protocol, so you essentially alleviate many of the problems. Yeah, that was my talk here. I'm Johan. I'm a part of now on Twitter and also on GitHub and on Mastodon. I blog regularly at Mostly Nurses. My most recent blog post was written yesterday because I walked so much over the High Line without any sunscreen on that I was like, it was quite hot, but I had good bagels from Russ and Daughters. They were really nice. So I had a nice time there, and then wrote a blog post on eBPF on how to generate 14,000 Java classes from something. So if you're more interested into debugging, profiling, and also eBPF, take a look there. You can find my team at Sweet Submachine on Twitter, and our webpage is submachine.io, where we offer more information. For example, you find there also in our GitHub wiki an article by a colleague who wrote on the problems with Loom, so how to deal with Loom issues and how to debug this. So if you want to know more, I'm here still for the evening. My plane is only leaving on Saturday. So and if you want to have some stickers, just pick a few. That's the Submachine. The reasoning of Submachine is simple. Name comes because it's like works under the surface with nobody noticing it. And it's a logo, and also this was drawn by a former colleague of us. And so it's a little tube here peeking out. And so thanks for having me here. Thanks for organizing it there in the back. It's really nice. And yeah, have a nice day.
Thank you, Johannes. And thank you, all people out in the internet land. We'll see you next month.
Any questions? Now it's the time.
I just wanted to add my comment here. No questions,
Yeah,
by
yeah.
the way, about Scala. I feel Scala is like the rebellious younger sibling of Java. Java has to look over everyone. Scala is like, no, I want to do it my way. But they belong to the
Oh.
same family.
Ooh, but I think so. Yeah, but I think like Scala is more like the child that goes to university and is like, I learned this, mom, I learned it, and now I know everything better. So I learned this, and it's like sometimes slightly arrogant. And it's like everyone should follow, and we will solve all the issues, and it's totally slow because it's so slow to implement. So yeah, use Scala if you like.
You can go crazy with Scala, real crazy with Scala, and it can become super hard to understand really quick.
And Scala is also the only language they know that like made incompatibilities in minor versions. So they had to worked on this. Had a problem with Scala a couple of years ago because from Scala 2.13 to 2.14, the collection libraries changed and it was incompatible. So you had a minor version change and it broke. You couldn't run applications that were developed with 2.14 with 2.13 on 2.14 compilers. So that's really good when you work on a larger project, because then every project had to decide, do we want to support 2.14 or 2.13, and so it was like Python 2 versus Python 3 all over again. But Python at least like changed the major version. But anyway, yeah, Scala has still its place. It's popular in machine learning. It's really cool when you are able to understand it. Any more comments on IDEs, language runtimes, or more?
Actually, I think we have to wrap pretty soon. I know everyone wants to head out for the holiday.
Yeah.
So thanks again, Johannes. So we wanted to raffle off more intelligent licenses, but since I think